We also need to learn about what are called unit vectors. Unit vectors are basically directions. They are vectors that have a magnitude of 1 unit, they have no dimensions, and they point along one of our coordinate axes. So the idea then is that if we have a vector that's 1 unit long, no dimensions, points along the positive x-axis, that's known as the vector I hat. That symbol over the top of I is pronounced I hat. And so I hat is a unit vector that points along the positive x-axis. The unit vector that points along the positive y-axis is known as j hat. And although we won't be doing too many things in 3 dimensions, if you do need to use a 3rd dimension, k hat is the name for the unit vector that points along the positive z-axis. So I hat, j hat, and k hat are vectors that basically represent directions and directions only. They have no dimensions and they're literally only 1 unit long. Once we know about unit vectors, then we can do what's called component notation. The idea of component notation is to write a vector as a sum of its components. So we have the vector A can be represented as its x component, which would be ax. That's the size of the x component times I hat. So ax I hat is literally a vector along the x-axis of the right length. And then we add to that ay times j hat. That's a vector along the y-axis. It's exactly the right length. And if we add those two together, that actually gives us the vector we're after. And another way of writing that is with brackets like this. So you can write the x component, comma, the y component in brackets. That's another common way of writing vectors in component form. So here is that same example that we looked at earlier. We have a vector A that's 8 meters long, and it makes an angle of 30 degrees clockwise from the negative x-axis. So what we want to do now is we want to find components. So think about the x and the y components. If we use standard horizontal and vertical axes, the x component is going to point to the left and the y component is going to point up. And we know the angle between the x-axis, the negative x-axis, and the vector is 30 degrees. So in order to get the x component is adjacent to that 30-degree angle. So we'd use a cosine. We would take 8 times cosine of 30 degrees, and that would give us 6.9 if we round it to 2 digits. But when we look at the picture, we can clearly see the x component is to the left, and so we have to add in that minus sign ourselves. So ax is negative 6.9 units. The y component is opposite that 30-degree angle that we know. And so the component that's opposite the known angle, we need to use a sine function. So if we take 8 times the sine of 30 degrees, we get 4 for our y component. And again, we can look at the picture, we can see that the y component points up, and so that's a positive 4. So if we wanted to write this vector in component notation, we could write it like this. A is equal to negative 6.9 I hat plus 4 j hat. Writing it like this is basically a description of how to construct the vector. You go 6.9 units in the negative x direction, and then you go 4 units in the y direction. You actually literally draw those out and add them together using that graphical method. That allows us to reconstruct the original vector. Of course, you could also write with brackets like this.